So, hello and welcome. Today we are going to start with current electricity. In this case, first lecture we will see about current, electric current and current in conductors. So, in this video we are going to cover about electric current, average current, instantaneous current, unit of current, drift velocity, analysis of current, free electrons means all the basic terms we can say that we are going to analyze in today's video, in this video. Okay. So let us continue. So first of all, when we say what is electric current, so can I say that electric current is nothing but flow of charge per unit time through a given area. And suppose if there is one wire, let us see this wire as given in the diagram. So per unit area, how much charge is flowing through this wire? That will be what current? So can I say current that will be equals to delta Q divided by delta T. If time is small, we can find the instantaneous value of current. Now, if you amplify this, or we can say magnify this small part, if you magnify this small part of the wire, so inside wire, what is happening? So we know that all the conductors they have free electrons and they will be moving randomly in the conductors. But when we apply electric field or when we apply a battery, so then what happens is these electrons gets direction and it will start moving in this direction, means opposite to the direction of electric field that we are going to see. So now the motion of electron is bit random, but for simplification we consider that they all are moving with some velocity like this. Simple. So if delta q amount of charge that passes through an area A, so we consider one wire having length is let us say L and area of cross section is A. So delta q is the amount of charge that passes through area A in time delta t. Then average current we can write I average that is equals to total charge flown in that time gap divided by delta t. So I average will be equals to delta q by delta t. Simple. Now, next is instantaneous current. Means suppose there is one wire and they say that find the current for time t equals to 5 second at for or in time t equals to 5 second. In that case, when time gap is there, then we have to write what I average. And when they say at any instant, like when t equals to 5 second, at that time what was the current flowing in the wire? So again we can say delta t that should be tends to 0, very small value. So we can write I equals to limit delta t tends to 0, delta q by delta t. That is nothing but dq by dt. Simple. So instantaneous current is given by the amount of charge passing through a conductor at any given instant of the time, and that is defined as the differential limit of the average current, or we can say it is instantaneous current. So I will be equals to dq by dt. Simple, right? Now, unit of electric current is what? So we know that current is unit of current is fundamental unit. It is current is fundamental quantity. So it is ampere. And ampere is just now we have seen the definition. Current is rate of flow of charge. So Q by T, right? So it will be what? 1 coulomb per second. And ampere is fundamental unit only. So SI unit of current electric current is ampere. If 1 coulomb of charge passes through a given area in 1 second, the current is said to be 1 ampere. So what is 1 ampere? So suppose 1 coulomb of charge passes through this area in 1 second. So that will be what? 1 ampere. 1 by 1 is 1. Simple. So let us solve one very simple question. Like equation for charge is given with respect to time, and we have to find current at t equal to 2 second and in t equals to 2 second. So here now we have given q that is equals to 2t square plus 1, and we want to find current at t equal to 2 seconds. So at t equals to 2 seconds, when we say, so at given instant we have to find current. So can I say this is nothing but I instantaneous, so that will be equals to dq divided by dt, right? So we can put the values. So we have d of 2t square plus 1 divided by dt. Now we can differentiate it, so it will be equals to how much? 4t. Now t is how much? 2 second. So we can say I at t equals to 2 second. So that will be equals to 4 into 2. That will be equals to 8 ampere. Simple. So which formula we have used? I instantaneous. I instantaneous. This is not instantaneous. That will be equals to dq by dt. Right? Simple, easy. Now, Similarly, suppose if I want to find current, not at current till t equals to 2 seconds, means when current was flowing through the wire. So in 2 seconds, how much current has flown, right? That means what? They are asking average value. So we know that when we write I average, so that will be equals to delta Q by delta T, right? So here now in t equals to 2 seconds, how much current has flown? So can I say that at t equal to 0, current flown is how much? C Q will be equals to, if you put the value of Q, so that will be equals to 2 into 0 plus 1. So that will be equals to how much? 1 coulomb. At t equals to 2 second, now how much charge has flown? So that we can write as 2 into 2 square plus 1. So it will be how much? 2 to the 4, 2 the 8 plus 1 9. So 9 coulomb, right? So can I say that delta Q that will be equals to 9 coulomb minus 1 coulomb, that will be equals to 8 coulomb? Yes or no? Time taken is 2 seconds. So we can write I average that will be equals to 8 divided by 2. So that will be equals to 4 ampere. So as you can see here, when we find current at t equal to 2, so that is how much? That value we got as 8 ampere. But when we write I average, so that is only 4 ampere. Why? Because as time increases, rate of flow of charge is increasing, right? So we can simplify like this. Clear to everyone? Now, let us solve a question. Question is for current is given as I equals to 2t square. So find the charge flown at t equals to 2 seconds. Means in 2 seconds how much charge has flown, that we have to find. So what was the formula we have to use? So till now in this chapter we have studied only one formula, that is I is equals to dq by dt, right? So what we want to find is dq, so that will be equals to I times dt, right? Now we can do the integration because it is variable quantity, current is variable quantity with time. So we can write integration of dq from 0 to t, so that will be equals to how much? That will be equals to integration of I, which is 2t square dt. Now we can write it as, sorry, 0 to q now. So we can write q that will be equals to 2t square, we can write it as how much? 2t to the power 3 divided by 3 integration, hope all of you know. From where to where? From 0 to 2 second. So this will be equals to 2 into 2 to the power 3 divided by 3. So it will be 16 by 3 coulomb. Simple, easy, right? Clear to everyone? So answer is, this is what we have done. Answer is 16 by 3 coulomb. Now next is if current is a scalar or vector, because when you see wires in home, so suppose there is one wire, so we say that okay, current is flowing in this direction, or when some wire enters at your home, so we can say that current is moving in this direction. So current has magnitude, of course, like 2 ampere, 5 ampere, whatever value is given, and it has direction also. So should we call current as a scalar or it is vector? What we should say? So let us see. So here now, if I ask you 3 ampere current is flowing in one wire and 4 ampere in different second wire. So how much current is flowing in this wire? So of course it is 7 ampere. Just we have added them, algebraic sum. There is no vector law we have followed. Here again, if 3 ampere current is flowing in this direction, 4 ampere in this direction. So in this wire again it is how much? 7 ampere, right? So what we are doing is we are just adding the vector sum. So there we are not, sorry, we are just adding the algebraic sum. We are not following the vector sum, right? So current is treated as the scalar quantity. In other words, current is called as tensor. Tensors are quantity in which they have magnitude and direction, but they doesn't follow the vector law of addition, which is out of our syllabus. So no need to worry for this. If they ask current is what, so we will say current is a scalar quantity, right? Why? Because it doesn't follow the vector law of addition. Just we have to do the algebraic sum to find the result. Simple. Next, current density. So when we say current density, that means current flowing per unit area, current density, right? So the electric current density is defined as the amount of electric current flowing or passing through a unit cross section area, and it is a vector quantity. So when we say current density, we represent it with J and arrow, means for a small part if I consider, so of course it has direction, so that is called as current density. So current density average will be total current flowing divided by area, right? If I want to write instantaneous current density, so that will be equals to di by dA. Simple. Clear to everyone? So here now suppose we consider that current flowing is delta I. Now area is given as like this, means area is at some angle from the current. As you can say, area vector is making angle theta from the current. So we will write I, that will J, that is equals to delta I by delta A cos theta, or delta we should not write, so directly we can write I will be equals to J is equals to I upon A cos theta. So if I want to write I, so it will be equals to I will be equals to J dot A, J dot A, that will give us what? Current density. So if current density is non-uniform, suppose at this point current density is some value is there, and as we move at different points current density is changing. So in that case we have to do the integration. For a small part we will write J dot dA, and we can do the integration to find the current, right? So current density is a vector quantity, and we can just remember J, that is equals to I by A, or if I want to write I, so that will be equals to J dot A. Simple, because area vector is vector quantity and J is also vector quantity. So we can just take the dot product. Clear to everyone? Simple, easy. So here now if it is at some angle, so what we can do is A cos theta we can take, right? Next. Next is a free electron. So we all know that if there is one conductor, so they have lot of free electrons, right? So what is free electrons? So the electrons which are loosely bound to the nucleus of an atom and free to move within the material when external energy is applied are known as free electrons. So when there are some conductors, or when the particle has free electrons, those free electrons can move throughout the surface or throughout the material. But if we apply some external energy, then it can move out also, right? And it is loosely bound, so we call it as free electrons. They are free to move throughout the material. Simple, clear? Now, when we say free electron and the motion of electron inside conductor, so there are some assumptions that we have to follow. So the classical free electron theory was introduced by P. Drude in 900 and developed by 1900 and developed by Lorentz in 1909 to explain conduction in metals, right? These are not that much important. Developed by some scientist, and to explain the conduction in metals. Why there is conduction when we apply some battery? So why current starts flowing through the material? That for explaining that, this free electron theory was developed. So what are the assumptions we are taking here? Assumptions are the valence electron of metallic atoms are free to move in the gaps between the ions within the metallic specimen. Means suppose there is one metallic wire we have taken. So these free electrons are free to move between the ions. They can move randomly, and there will be collision between the ion and electron, between electron, and so on. So these electrons are also called as conduction electron, because these electrons are responsible for conduction. So they are called as conduction electrons also. Simple, one assumption. They are free to move in the gaps between the ions and within the metallic specimen. Okay. Next is there is no interaction between these conduction electrons, means when they are moving. So between them, of course, collision may be there, but there is no force of attraction or repulsion, or we can say Coulomb's law are very negligible. Force due to Coulomb's law is very negligible. Interaction of the free electrons with ions is also negligible. Between this plus charge and minus charge, the interaction is very negligible. Simple. Next is the free electrons find uniform electric field of positive ions. The free electrons find uniform electric field of positive ions. So due to these all ions, all these electrons, they have free, we can say electric field due to these positive ions, and since they are not interacting, so due to these ions there will be no effect on these electrons. Simple. Now again some data not important for us. Like if you see conduction band electron density, so for aluminum it is highest, then beryllium, then copper, and so on. So not important for us. Next is analysis of a simple circuit. So now basics of what is happening inside the wire we had seen. Now if I draw one circuit, so what are the different components that we are going to see? So analysis of simple circuit in this, if I want to represent a battery, so battery is represented with, suppose this is one cell, so this is your positive charge and this is negative. This is the cell, right? So if I want to write in circuit, so what I will do is negative charge a smaller line and positive charge means two parallel lines are there. The line which is smaller, that is called as negative sign, and the line which is bigger, that is called as positive line. Like this we can write. So here as you can see, plus minus, plus is bigger line, minus is a smaller line. So this is symbolic representation of cell. Now resistance, one zigzag line we draw like this. So this is nothing but resistance, and switch means the circuit has broken. So here now if we connect it, it will become switch on. So switch is represented like this. Simple. So these are components of circuit we can say. So positive ion means higher potential, a smaller line means lower potential or negative ion potential, right? So let us solve one question. Question is, find the value of x in the following case. So x is how much? 15 volt is the potential difference between these 2 points. So if this is 2 watt, x will be how much? In second case, 8 volt is the potential difference between positive and negative ion. So if this is 18 volt, this will be how much? So all of you please try. It's very simple question, very easy. How much will be the value of the ions? So see here, can I say that in first case, suppose this is x, and as we move from positive towards negative, so delta V is how much? 15. Delta V is how much? Potential difference is 15 volt. Can I say that delta V is nothing but positive minus negative? So x minus 2, that is equals to how much? 15. So x is how much? 15 plus 2, that is nothing but 17 volt. Yes or no? In second case again we can write 18 minus x, this is for case 2. So now we can write 18 minus x, that will be equals to how much? 8. So can I say that x will be equals to, x we move on right side, so x will be equals to 18 minus 8, sorry 18 minus 8, so that will be equals to how much? 10 volt. Yes or no? Simple. So answer is what? 17 volt and 10 volt, that is B, right? So simple answer question, x minus 2 positive higher potential minus lower potential, that will be the potential difference across the terminals of the battery, right? Now next is, so answer will be B, which we have solved. Next is now a few more components, let us see. So next is now when we say that electron is flowing, so in which direction electron is flowing? Here now when we have applied the battery, so this is higher potential plus sign, this is lower potential minus sign. So can I say that now direction of electron will be in which direction? So this point is higher potential plus, this is minus, right? So direction of electric field will be from positive towards negative, means in this direction electric field will develop. Now electrons, they are having negative charge minus q, so they will move opposite to the direction of electric field. We all know na, force due to electric field is q into E. Now q is negative, so direction of force acting on these electrons will be opposite to the electric field, right? So they will start drifting opposite to the direction of electric field. So electrons will move like this, or we can also think like here there is positive charge, so deficiency of electrons, so it will attract electron towards it. Here there is lack, negative charge means excess of electron, so it will supply electron like this. Yes or no? So when the wire is connected, we assume that for connecting wires, resistance of these connecting wires are very negligible, so we consider them as resistance is 0, right? Potential difference across conducting wire is also equal to 0. Means at this point at this point, up to this point. There is no other component, only connecting wire is there. So for all these points, potential difference will be 0 or potential will be same, right? Now, if I consider, let us say this is point A, this is point B. So for A and B, of course, potential will not be equal because there is some component. It can be resistor. In this case, it is battery, right? Clear to everyone? Now, next is a battery is called as source of energy, and resistor is called as consumption energy. Consumes energy, resistor consumes energy, and battery is source of energy, and charges are transporter of energy. So we can say that this battery is transporting energy in which method? By electrons or charge. Simple. Now, next is one important concept that is called as drift velocity. So, what is drift velocity? Let us see. And direct questions they have asked many times on this drift velocity. So, what happens inside the conductor is when there is no battery connected or there is no external electric field, means we have not developed electric field in between the uh, this wire. So in that case, all these free electrons, we have considered one electron. So let us say this is point A, this is point B. So it will keep on moving in random directions like this, like this, like this, and lot of zigzag motion will be happening, and the collisions are happening, and they will be moving. Net displacement for a given interval of time will be 0 only, right? So net displacement is 0 because it is not moving away from the material, right? And in this case, we know that distance is length of path travel. So of course, distance is not equals to 0. So if distance is not equal to 0, then of course speed is not equal to 0. But average velocity will be how much? 0, right? So when no potential difference is applied across the conductors, then average velocity of these free electrons will be 0. There is no drift of the free electrons, thus net current is 0, right? Now, when we applied one battery or we have developed one potential difference, so let us say in this case, this is negative charge, this is plus charge, higher potential, lower potential. So electric field is in this direction, right? So when potential difference is applied across the conductor, now net displacement of these electrons are not equal to 0. Initially, it was started from here. So if I check after some times again, it will come back at this place. But now since a force is also acting, so it will drift little bit. So let us say this drift is L, or let us say D. Let us say this drift is X, this much distance it has moved, or in time T. So here now net displacement is also not 0, net speed was not 0, average velocity is also not 0 because there is some drift velocity. This average velocity is called as drift velocity. So of course speed will be greater than drift velocity because distance by time. So of course distance will be higher. Yes or no? Distance is total path and displacement is only x. So of course speed will be much higher compared to drift velocity, right? Drift velocity is nothing but we have considered average velocity for given interval of time, how much the electron has shifted in the direction of electric field, right? Hmm. Okay, sorry. In the opposite direction, in the opposite direction of the electric field, force is acting in opposite direction, right? Now, so this is all from this video. We will continue in the next video about the drift velocity. Okay. So thank you everyone.